We are now going to work the molar volume two-step problems, or they may be called molar volume multi-step problems. We're now going to be focusing on incorporating the volume and the 22.4 liters. Again, there's not a direct path from your volume to your mass, so you have to go volume to moles to mass, or mass moles to volume. And the same thing with your number of molecules. You have to go volume to your moles, then your number of molecules using Avogadro's number, or vice versa. Your number of particles or your molecules to moles to your volume. So let's take a look at problem number 1. In number 1, it wants to know how many liters of nitrogen are in 3.01 times 10 to the 23rd molecules of nitrogen. So we're starting in our molecules box. So we'll put the 6.02 times 10 to the 23rd molecules of nitrogen in the bottom, and we're going to moles. So moles of nitrogen go in the top, and since the substances are the same, it's to 1 mole. Then we're going to go moles of nitrogen to our liters of nitrogen, and the 22.4 will go in the top, and since the substances are the same, it's to 1 mole. So we take the 3.01 times 10 to the 23rd times 1 times 22.4, which is 6.74 times 10 to the 24th. And then we take the 6.02 times 10 to the 23rd times 1, which is 6.02 times 10 to the 23rd. Divide, and our answer is 11.2 liters of N2. Remember, the worksheet likes to use decimeters cubed in place of liters, but it's the same unit. Number 1 is a model for 2 through 4. Let's take a look at number 5. Number 5 wants to know what is the volume, or how many liters of oxygen gas if we have 32 grams of oxygen. So this time we're going to put the mass down here in the bottom, and our moles of oxygen will go in the top. Oxygen has the mass of 16. Since there are 2 oxygen, our mass is 32 here, and we'll put 1 here because it's the same substance. Then we go moles of oxygen, then to our volume of oxygen, and that's when we use the 22.4 liters. We take the 32 times 1 times 22.4, that's 716.8. We take the 32 times 1, which is 32, and we divide, and our answer is 22.4 liters of oxygen. Notice the moles cancel out, the mass cancels out, and we're left with our volume in liters. If we look at number 1, our moles cancel out, our molecules cancel out, and we're left with liters up here. Number 5 is a model for 6, 7, and 8. Let's take a look at number 8. And if I'm going too fast, you may need to pause the video at this point so you can finish writing down the information, and then we can continue playing. So in number 8, we want to know how many grams of nitrogen if we have 44.8 liters of nitrogen. So this time we're going to have our 22.4 liters of nitrogen in the bottom, and our moles of nitrogen will be in the top. And since both substances are the same, it's to 1 mole. Then we'll go moles of nitrogen in the bottom to our mass of nitrogen. And nitrogen has the mass of 14. Since there are 2 nitrogen, our total is 28. because 14 times 2 is 28. Since the substances are the same, it's to 1 mole. So we take 44.8 times 1 times 28, and that's 1,254.4. We take the 22.4 times 1, which is 22.4, divide, and our answer is 56 grams of N2. Our moles cancel, and our volume cancels, and we're now left with our mass. 8 is a sample for, or an example for, 9 and 10. So let's take a look at number 11. In number 11, we want to know how many molecules of O2 if we have the volume of 11.2 liters of oxygen. Remember, decimeters cubed is the same thing as a liter. Then we're going to take 22.4 liters of oxygen to 1 mole of oxygen because it's the same substance, so that's why it's 1. Then we're going to go 1 mole of oxygen to our molecules of oxygen, and that's when we use Avogadro's number, the 6.02 times 10 to the 23rd molecules of oxygen. And since the substances are the same, it's to 1 mole. Then we take 11.2 times 11.2 times 1 times 6.02 times 10 to the 23rd, and that gives us 6.74 times 10 to the 24th. Then we take 22.4 times 1, which is 22.4. We divide those out, and our answer is 3.01 times 10 to the 23rd molecules of oxygen. So our moles cancel, our liters cancel, and we're left with molecules. 11 is a model for 12 through 13.